Okay, today we're looking at section 11.3, standard divisors, standard quotas, and the apportionment problem. So in our new democracy of Imaginaria, there are 4 states: Fictionville, Pretendstead, Illusionham, and Missberry. Each state will have representatives in the Imaginarian legislature. You might have to have an agreement on which voting method your citizens will use to elect their representatives. However, before that process can even begin, you must decide on how many representatives each state will receive. This decision will present its own challenges. When sharing your birthday cake, it's only fair that everybody gets the same portion size, right? You're portioning the cake by dividing it up equally and giving everyone a slice. Great thing about cake is you can slice it any way you want, but how do you apportion or divide and distribute items that can't be sliced? Suppose you have a box of 16 ring pops, which are gem-shaped lollipops on a plastic ring. You're going to share the box with 4 other kids. Dividing the 16 ring pops among the group of 5 leads to a problem. After each person in the group gets 3 ring pops, there is still 1 left. Who gets the last one? The apportionment problem is how to fairly divide or apportion available resources that must be distributed to the recipients in whole, not fractional parts. The apportionment problem applies to many aspects of life, including the representatives in the Imaginarian legislature. The table below provides a short list of examples of resources that must be apportioned in whole parts, and the recipients of those resources. So we could have our COVID-19 vaccines distributed to the nations around the world, airport terminals distributed to airlines, faculty positions at a university distributed to departments, public schools distributed among communities, U.S. House of Representatives seats distributed among the states, and parliamentary seats distributed among political parties. Fair division of a resource is not necessarily equal division of the resource, like when distributing cake slices. When distributing airport terminals amongst airlines, there are many factors to consider, as the size of the airline, the number of types of aircraft they have, and the demand for the service. In most cases, fairness is defined as being proportional. 2 quantities are proportional if they have the same relative size. In the case of the COVID-19 vaccine, the expectation would be that countries with larger populations get more doses of the vaccine. In the Imaginarian legislature, the expectation may be that states with larger populations will receive the larger number of representatives. This concept is referred to as part-to-part ratio. Now, suppose the supermarket has a special on pies. 2 for $5. First customer purchased 4 pies for $10. Second customer purchased 8 pies for $20. The dollar to pie ratio for the first customer is $10 to 4 pies, or $2.5 per pie. And the dollar to pie ratio for the second customer is $20 to 8 pies, which is also $2.5 per pie. So the dollar to pie ratio is constant. Although the customers do not spend the same amount of money, the amount each spent was proportional to the number of pies purchased. Now suppose that the supermarket changed the special to 5 for the first pie and 2 for each additional pie. In that case, 4 pies would cost $11 over 4 pies, which is $2.75 per pie, while 8 pies would cost 5 plus 7, or 19. Oh, something wrong there. That should be 5 plus 14. The dollar to pie ratios would be $19 to 8 pies, or $2.375 per pie, respectively. This special does not result in a constant part-to-part ratio. Dollars spent are not proportional to the number of pies. Let's look at an example here. The SAT is to be administered at a high school. and preparation pencils have been distributed to each of the classrooms based on the room capacity. We'll use the information in the following table to answer each question. Now here's our table. We have room B, C, D, and E. We have the capacities, and we have the number of pencils. The first, find the part-to-part ratio of desks to pencils for each room, represented as both a reduced fraction and a decimal rounded to the nearest hundredth as needed. So looking at B, and we want desk to pencils. So desk to pencils. So B would be 24/36. Reducing the fraction would be 2/3, which is 0.67 roughly. In room C, we have 18 to 27, which will also be 2/3, or 0.67. In room D, we have 32 to 48, which would also be reduced to 2/3, or 0.67. And in room E, we have 22 to 33, which is also 2/3, or 0.67. So the ratio is the same. Now find the part-to-part ratio of pencils to desk for each room. So in this case, pencils on top, desk on bottom. So we have B, it would be 36 to 24, which would be 3/2, or 1.5. C would be 27 to 18, which would also be 3/2, or 1.5. D would be 48 to 32, which will also be 3/2, or 1.5. And E would be 33/22, which would also be 3/2, or 1.5. Have the pencils been distributed proportionally? Yes, the proportions are the same. And what is the constant ratio of pencils to desk? Pencils to desk is 3/2. Each desk receives 1.5 pencils, which is not possible, really. So there are some useful relationships between quantities that are proportional to each other. When there is a constant ratio between two quantities, the one quantity can be found by multiplying the other by that ratio. Remember the supermarket special on pies, 2 pies for $5? The ratio of dollars to pies is 5 to 2, or 2.5 dollars per pie. Ratio of pies to dollars is 2 to 5, or 0.4 pies per dollar. These two values are reciprocals of each other. 1/2.5 is equal to 0.4, and 1/0.4 is equal to 2.5. This means that multiplying by 1 has the same effect as dividing by the other. Also means that knowing either constant ratio allows us to calculate the price given the number of pies. To find the cost of 20 pies, multiply the ratio of dollars to pies, or divide by the ratio of pies to dollars. The 20 pies times $2.5 per pie is $50, or 20 pies divided by 0.4 pies per dollar is $50 as well. So these patterns are true in general. So if we let A be a particular item and B another such that there is a constant ratio of A to B, the ratios of B's to A's is 1 over the ratio of A's to B's, and the ratio of A's to B's is equal to 1 over the ratio of B's to A's. The units of A is equal to the units of B times the ratio of A's to B's. In other words, the units of B's divided by the ratio of B's to A's. And the units of B's is equal to the units of A times the ratio of B's to A's, or the units of B divided by the ratio of A's to B's. So let's go back to our table, our classroom capacities, and see what we got going on here. So determine the number of pencils that would be allocated to classroom F with 28 desks by multiplying the number of desks by the ratios of pencils to desk. Well, the ratios of pencils to desk was 3 to 2. So we have 28 times 3 to 2, which is 84 over 2, or 42 pencils. Determine the number of pencils that will be allocated in classroom F with 28 desks by dividing by the number of desks, by the ratio of desks to pencils. So here we'll go 28 times 0.67, 2/3. Oh no, let's do 2/3. Stick with fractions. 56 over 3, which again would be wait, we're dividing, so we are going to use this, which would give us 42 pencils. Because if you recall from your early algebra, dividing by a fraction is the same as multiplying by the reciprocal. Assuming the pencils continued to be distributed in the same manner, if there were another classroom G that received 51 pencils, how many desks would you find in the room? So we could take 51 pencils divided by 3 halves, and that gives us, or divided by 1.5, gives us 34 desks. Apportionment application that will be important to the founders of Imaginaria occurs in representative democracies in which elected persons represent a group. The United Kingdom, France, and India each have a parliament, and the United States has a Congress, just as Imaginaria will have a legislature. The citizens of the country must decide what portion of the representatives each group, such as a state or province, or even a political party, will have. Larger portion of representatives means greater influence over policy. Now here in table below we have list of 5 U.S. states ranked 6th through 10th in the number of representatives in the House of Representatives, along with the population of that state in 2021. Let's use this information to answer the questions. Okay. So what is the ratio of state population to representative seats for each state to the nearest 100,000? So we would simply take the population divided by the representatives and then round to 100,000. So when doing that, we get Illinois is 700,000. Ohio is 700,000. Michigan is 700,000. Georgia, however, is 800,000. and North Carolina is 700,000. Again, rounded to the nearest 100,000. Next, we're going to, what is the ratio of representative seats to state population for each state rounded to 7 decimal places? So here, we're going to take this and divide it by this. And we end up with Illinois being 0.12345 zeros and 1 4. And of course, Ohio is going to be the same, as well as Michigan. That's the 7 decimal places. Georgia, however, 0.000013. And North Carolina, North Carolina will go back to 1 4. So note Georgia is a little different, just as Georgia was a little different. However, what happens, and what is the representative seats state population for each state rounded to 6? So note 4, 4, 4, 3, 4. None of them round up, so they're all to be 0.000001. Does this appear to be a constant ratio? And we don't have the top 5 states, so we can't answer that question. And there does appear to be a constant ratio of seats to population and rounding to 6 decimal places. So you might be wondering why the ratio doesn't appear to be quite the same depending on the rounding of the values. Well, we'll see that the key to this variation lies in the fractions. Just like the 5 children sharing 16 ring pops, there are going to be leftovers, and there are many methods for deciding what to do with those leftovers. So next we have what's called a standard divisor. There are 2 houses of Congress in the United States, the Senate and the House of Representatives. Each state has 2 senators, but the number of representatives depends on the population of the state. The number of representative seats in the U.S. House of Representatives is currently set by law to be 435. In order to distribute the seats fairly to each state, the ratio of the population of the U.S. to the number of representative seats must be calculated. The ratio of the total population to house size is called the standard divisor, and it is the number of members of the total population represented by 1 seat. Although apportionment applies to many other scenarios, such as the pencil distribution during the SAT, terminology of apportionment is based on the House of Representatives scenario. Thus, several government-related terms take on a more general meaning. The states are the representative or the recipients of the total number of seats to be apportioned. State population is the measurement of the state's size, and the total population is the sum of the state's population. So our standard divisor is equal to the total population divided by the house size. So by the end of the first U.S. Congress in 1791, there were 13 states, 65 representative seats, and approximately 3,929,214 citizens. Find the standard divisor rounded to the nearest tenth. So our standard divisor is equal to the total population, 3,929,214, divided by the number of seats, 65, which is 60,449.4. Okay. The Hernandez family and the Higgins family went trick-or-treating together for Halloween last year. They returned with 313 pieces of candy, which they will now apportion to the families. The Hernandez family has 3 children, and the Higgins family has 4 children. Identify the states, seats, and house size and state population. Well, our states are the Hernandez family and the Higgins family. Our seats are the pieces of candy. That's what we're going to divide out. House size, well, the Hernandez, the house size is 3 plus 4 or 7. Hernandez family population is 3, Higgins is 4. Now describe the ratio the standard divisor represents in this scenario and calculate it. Standard divisor is the ratio of the number of children to the number of pieces of candy. So our standard divisor is 7/313, or roughly 0.0224. Okay, next we look at what's called a standard quota. Once the standard divisor for the imaginary legislature is calculated, the next task is to determine the number of seats that each state should receive, which is referred to as the state standard quota. Unless all the states have the same population, each state will receive a different number of seats because the quantities will be proportionate to the state populations. To determine those amounts, we will use an idea we learned earlier. Recall that when the number of units of an item is proportionate to the number of units of item B, we have units of A equals units of B over a ratio of units to B to A. In this case, we are trying to calculate the number of seats the state should be apportioned, the state standard quota. So A. So A would refer to the seats allocated to a particular state, while B would refer to the state population. That means the ratio of B to A is the ratio of the total population to house size, which is the standard divisor. So in apportionment terms, we have the following formula. State standard quota equals state population divided by standard divisor seats. So again, by the end of the first U.S. Congress in 1791, there were 13 states, 65 representative seats, and approximately 3,929,214 citizens. And that year, the state of Delaware had a population of approximately 59,000 people. Use this information in the standard divisor you found in example 1127 Define Delaware standard quota rounded to 2 decimal places. So our standard quota is the state population, 59,000, over the standard divisor, which was 60449.4, which is roughly 0.98. Okay, so let's visit our Halloween families again. This year, the Hernandez family and the Higgins family were joined by the Ho family for Halloween trick-or-treating. Hernandez family has 3 children, Higgins has 4, and the Ho family has 2. This time they collected 527 pieces of candy, which they're going to apportion based on the number of children. Find the standard quota for each family, round all values to 4 decimal places. If traditional rounding methods are applied to determine the actual whole number values of pieces of candy received by each family, do the values of sum to 527. So let's start with our 3 families. We have Hernandez, we have Higgins, and we have Ho. Hernandez has 3, Higgins has 4, Ho has 2. So our total population is 9. So our number of seats, our number of pieces of candy, 527. So our standard divisor is 9 divided by 527. The 4 decimal places, I actually went to 5, 0.01708. So what we do now is we take 3, the population, divided by our standard divisor, and I get 175.6440. Here I have 4 divided by our standard divisor. I get 234.1920. And here I have 2 divided by our standard divisor. I get 117.0960. Now, using traditional rounding, this rounds down to 117. This rounds down to 234. This rounds down or up to 176. And we end up with 527. So yes, it does work out. One of the rare instances where that is the case. And that finishes this section.